As we move into the end of Module 2 in Unit 1, we want to take a look at one of the most important units that we use in chemistry, and it sometimes has seen as a funny name, but it's called the mole. So let's say that I ask you to go to the store and buy a dozen eggs. A dozen eggs is 12, right? We understand that the word dozen means 12. Well, that's kind of what the mole is. The mole is a way of signifying a certain number of particles, and it can be anything. It can be atoms, molecules, protons, electrons, eggs, people, money. It doesn't matter, okay? So the mole means 6.022 times 10 to the 23rd particles. That number is called Avogadro's number. It's named after Amadeo Avogadro, okay? So the conversion factor is, if you want to convert from number of things to a mole, you use Avogadro's number. 1 mole of anything is 6.022 times 10 to the 23rd things. That number is huge, okay? One really quick way of trying to help you understand that number. If you were born counting, the moment you were born, you started counting, and you could count at the rate of 1 number per second from birth, and you never stopped, it would take you 19 trillion years to count to that number. That's enormous, okay? The reason we have such a large number is that we're dealing with unimaginably tiny particles. Atoms are tiny. The subatomic particles are even tinier. So you've got to think about it takes a lot of them to make the tangible samples that we're able to see and use. Okay? So we're going to look at converting between moles and other things for elements in this chapter. In later chapters, we'll look at it for molecules and things like that. But there's this little map here, and it's a mini mole map, we'll call it. It shows you converting from number of atoms, and it uses aluminum in this particular example, to moles of atoms. And underneath here, it has 1 mole of aluminum is Avogadro's number of aluminum atoms. So what that's saying is, to go from atoms to moles, you're going to divide by Avogadro's number. Doesn't matter if it's aluminum, copper, whatever. You're going to divide by Avogadro's number. And then to get it into something measurable, because again, remember, we can't count to Avogadro's number, and we don't have a piece of equipment that measures moles, but we do have scales that measure grams. So if we can get that number transferred into grams, it becomes a more practical number. So to go from moles to grams, it says 26.98 grams of aluminum over 1 mole. That's the atomic mass for aluminum. Okay? So essentially, it's telling you to multiply by atomic mass. And then this map takes you one more step. If you wanted to go from grams of aluminum to, say, volume in cubic centimeters, okay? Anytime you're converting between grams and volume, you're using density. Because remember the triangle? Density is mass over volume. So density is a conversion factor between mass and volume. So in this case, it has 1 cubic centimeter over 2.70 grams of aluminum. That's the density of aluminum. So it's telling you to divide by the density to go from grams to volume. And again, if we did our trick with the triangle here, mass divided by density is volume, which is what this is telling us to do. Now, it doesn't have the arrows going, and I'm not going to draw them in, but if we were starting with volume and going the other direction, the operations would switch. So instead of divide, it'd be multiply, things like that. Okay, so let's take a look at a couple of examples here. A ring contains 2.8 times 10 to the 22nd silver atoms. So we know the atoms. How many moles of silver does it contain? How many grams? Well, according to this mole map, we're going to divide by Avogadro's number. So 2.8 times 10 to the 22nd silver atoms. Is where we're starting. 1 mole of silver, and the abbreviation for mole is officially MOL. I know, a 4-letter word with a 3-letter abbreviation, but just go with it. We're going to divide by Avogadro's number. So back in the first video, I was telling you how important it was to make sure you knew how to use your scientific notation on your calculator. This is why. Okay. So this comes out to be 0.0465 moles of silver. So we got our answer to the first question. And then it asks us for grams of silver. So we're here, we're trying to go there. So we're going to take the moles that we just found, and we'll have to go look up silver on the periodic table, find its atomic mass. It is 107.9 grams of silver for every 1 mole of silver. So the atomic masses, we originally talked about them in terms of atomic mass units, but they are also the equivalent of the grams for 1 mole of those atoms. Okay? So when you're converting from moles to grams, you're going to multiply by that atomic mass and get rid of moles of silver. And it's going to be 5.02 grams of silver. Now, that gives you something that you could easily go into the lab and measure. 2.8 times 10 to the 22nd atoms. It's good to know how many atoms are there, but that's not really practical. It's not measurable. Okay? So I think I'm going to cut the video here and do one more with these last 2 examples, just so we have plenty of time.